In the late Victorian era, when Britain was still a nation of horse-drawn carriages, coal smoke and gas lamps, a boy was born in London who would one day help shape the sound and soul of the modern motorcar. His name was Harry Ricardo, and over the course of nearly 9 decades he would touch almost every frontier of combustion technology. From the clattering two-strokes of Edwardian motorcycles, to the thunderous tank engines of the First World War, to the sophisticated high-compression diesels and even the birth pangs of the jet age. Ricardo's story is not one of a flamboyant showman like Ettore Bugatti, nor of a charismatic tycoon like William Lyons of Jaguar. He was a quieter force, a thinker and a problem solver whose great gift was to imagine what was happening inside a sealed cylinder, at a time when no camera could peer inside. His legacy isn't just one famous car or engine, but the very principles by which engines have been designed for more than a century. This is the story of Sir Harry Ricardo, the engineer whose life's work defined the pursuit of efficiency and performance, and whose ideas still echo every time a piston fires. Harry Ricardo was born on the 26th of January 1885 in Bedford Square, London. He came into a world that was rapidly changing. The Industrial Revolution was in full bloom, electricity was beginning to challenge gaslight, and only a few years earlier Carl Benz had rattled down a cobbled street in his primitive 3-wheeled motorcar. Harry's family background gave him an unusual head start. His father, Halsey Ricardo, was a respected architect, while his maternal grandfather was Sir Alexander Rendell, a distinguished civil engineer. The Ricardos were also distantly related to the economist David Ricardo, whose theories on value and free trade were shaping public policy across Britain. So from the beginning, Harry's dinner-table conversations were likely filled with talk of design, mechanics, and progress. The defining moment of his childhood came in 1898. Harry's grandfather purchased an early motor vehicle, a Benz dog cart producing all of 3.5 horsepower. To the 13-year-old Harry, this noisy, sputtering contraption was a vision of the future. From then on, he was hooked. He set about building miniature engines at home, fueled by coal, gas, and curiosity. The mechanical world wasn't just something to study, it was something to live and breathe. When Harry entered Trinity College, Cambridge in 1903, he was nominally there to follow in his grandfather's footsteps by studying civil engineering. But he was quickly drawn to the world of engines. He found a mentor in Professor Bertram Hopkinson, a brilliant engineer who was among the first to explore combustion scientifically. Under Hopkinson's guidance, Ricardo began to hone his gift for practical experimentation, combined with theoretical insight. The first taste of victory, the fuel economy contest. In 1904, a unique challenge was issued by the University Automobile Club at Cambridge. Build a machine that could travel the farthest on a single quart of petrol. At a time when most cars guzzled fuel with little thought for efficiency, this was an unusual competition. Ricardo entered with a small single-cylinder motorcycle engine he had designed and built himself. It was not elegant. In fact, it was the heaviest engine in the contest, but it was brilliantly efficient. His machine covered an astonishing 40 miles on a single quart of fuel, winning the competition comfortably. For Ricardo, the victory was more than a student triumph. He later recalled that it gave him greater pride than many later, and more famous, successes. Because it was the first proof that his ideas about combustion efficiency were correct. This fascination with fuel economy would become a hallmark of his life's work. While others were obsessed with sheer horsepower, Ricardo understood that extracting the maximum energy from every drop of fuel was the real key to progress. After graduating in 1906, Ricardo spent a year assisting Hopkinson with research before briefly joining his father's firm. But by 1908, his passion for engines was impossible to suppress. That year, at just 23, He founded the two-stroke engine company with his cousin Ralph Ricardo. Harry designed a unique two-stroke engine called the Dolphin, a 3.3-litre unit with a novel split-cycle design. The original plan was to install it in a light car, but the vehicle never reached production. Instead, the engines found their way into fishing boats and small automobiles, where they proved reliable and effective. The company even built around 50 units before shutting down in 1911, when Ralph left for India, and the venture lost momentum. Though the Dolphin car never materialized, the project gave Ricardo invaluable experience: filing patents, running a small company, solving manufacturing problems, and translating theory into working machinery. He had established himself as a capable engineer with fresh ideas, even if he was still a young man on the periphery of Britain's industrial giants. The outbreak of World War I in 1914 transformed Ricardo's life. Britain, though a global empire, was surprisingly dependent on foreign, especially German, engine technology. The war created urgent demand for reliable, powerful engines for ships, trucks, and above all, the newly invented tank. By 1915, Ricardo was working with the Royal Naval Air Service as a consultant, offering advice on diesel engines for submarines. But it was the problem of the tank that became his defining wartime contribution. The first British tanks, lumbering beasts with steel armour and rhomboid tracks, were powered by a 105-horsepower Daimler engine. These early tanks were noisy, slow, and smoked like bonfires, betraying their presence to the enemy and choking their crews. The army asked Ricardo to help. He quickly concluded that the Daimler sleeve valve engine was unsuited for tanks. Instead, he proposed designing an entirely new engine from scratch. It was an audacious suggestion. Britain's factories were already stretched to their limits with war production, but Ricardo convinced them it was the only viable path. His design, completed in 1917, was a 6-cylinder, 19-litre petrol engine. Despite fitting into the same space as the old Daimler, it produced 150 horsepower, half again as much, and did so with far less smoke. With further development, the output climbed to 225, even 260 horsepower, without enlarging the unit. It was an astonishing achievement. At the height of the war effort, production reached nearly 100 engines per week, and more than 8,000 Ricardo tank engines were ultimately built. These power plants transformed the British Mark V tank into a far more formidable machine, giving it the muscle to cross trenches and push through mud where its predecessors had bogged down. Historians have argued that Ricardo's engine was one of the crucial technological contributions that allowed tanks to play a decisive role in the final Allied offensives of 1918. For his efforts, the British government awarded him a £30,000 prize, acknowledging the impact of his work on the war effort. That engine has since been remembered as Britain's first mass-produced internal combustion engine, a title that places it firmly in the pantheon of engineering breakthroughs. Even as he solved the army's problems, Ricardo continued to pursue his own burning question. Why did engines knock? Knock, the destructive rattle caused when fuel ignites too early or unevenly, was the bane of high-performance engines in the early 20th century. It limited compression ratios, wasted fuel, and often destroyed pistons and valves. Ricardo's unique gift for visualizing the combustion process helped him make sense of the problem. In his writings, he invited readers to imagine sitting on top of the piston inside a cylinder, watching the flame front race across a swirling cloud of fuel and air. Through painstaking experiments with his variable compression test engine, Ricardo discovered that the resistance of a fuel to knock depended on its chemical structure. Some fuels could withstand higher compression before auto-igniting. From these studies emerged the Octane number system, a standardized way of grading fuels by their knock resistance. This development was transformative. It allowed petroleum companies to produce fuels of predictable quality, and It gave engineers the confidence to design higher compression engines that delivered more power and better fuel economy. Octane ratings are now printed on every petrol pump in the world, a silent but enduring legacy of Ricardo's research. With peace restored after World War I, Ricardo expanded his company's role as the world's first dedicated engine research consultancy. Unlike car makers who guarded their designs jealously, Ricardo's team specialized in helping others, testing prototypes, solving combustion problems, and licensing patented technologies like the turbulent cylinder head and the comet chamber. The firm worked with virtually every major British manufacturer, from Rolls-Royce and Bentley to Vauxhall and Austin. Abroad, companies like Citroën and later Fiat and Ford sought Ricardo's expertise. In the 1930s, Ricardo's comet chamber design revolutionized the diesel engine, making high-speed diesels practical for cars and trucks. The Citroën Rosalie with a Ricardo diesel became a landmark, the first diesel passenger car to be sold to the public. Over the following decades, the Comet design was licensed worldwide, shaping diesel technology well into the 1980s. The consultancy also contributed to motorsport. Ricardo cylinder heads powered Triumph motorcycles and even featured in record-breaking racing cars. His four-valve Triumph engine set new standards for performance, presaging the multi-valve revolution that would dominate high-performance engines decades later. Perhaps more than any single invention, though, Ricardo's company represented a new idea, that of the independent engineering consultancy. Before him, manufacturers jealously protected their in-house designs, rarely sharing expertise. Ricardo showed that a neutral, research-driven organization could accelerate progress across an entire industry. By the late 1930s, his lab at Shoreham was one of the world's most respected centers for engine development. When Britain once again found itself at war in 1939, Ricardo was ready. He and his team played critical roles in multiple projects, from refining the Rolls-Royce Merlin engines that powered Spitfires and Lancasters, to advising on diesel tank engines and submarine power plants. His oxygen enrichment system gave high-altitude aircraft like the de Havilland Mosquito an extra edge in performance. But perhaps the most ambitious project of this period was the Rolls-Royce Cressy. This extraordinary two-stroke sleeve-valve V12 engine was unlike anything else flying at the time. Designed with Ricardo's input, it combined direct fuel injection with a highly supercharged cycle that promised over 2,500 horsepower, double the output of a typical piston aero engine. Ricardo considered the Cressy the ultimate expression of piston engine design, yet history intervened. By the mid-1940s, jet propulsion had matured, and the Cressy was quietly shelved. Its data, however, fed into future work, including long-range piston engines and post-war research into alternative power plants. In fact, Ricardo himself contributed directly to early jet development. He designed a barometric fuel control that adjusted fuel flow automatically with altitude, ensuring stable combustion in Whittle's pioneering jet engines. This contribution helped make Britain's early jets reliable enough to enter service before the war's end. By the conclusion of World War II, Ricardo had cemented his status not just as a problem solver but as a visionary. He had been central to the last great leap of piston engines, and at the same time he had helped lay foundations for the jet age. While his wartime work was critical, Ricardo never lost sight of the motorcar, the machine that first captured his imagination as a boy. The interwar period had seen him revolutionize petrol and diesel engines, and in the post-war years, those innovations bore fruit. His Comet swirl chamber became the cornerstone of diesel engine design for cars, trucks, buses, and tractors. Car makers across Europe licensed the design, and it gave rise to a new generation of diesels that were quieter, cleaner, and more efficient than their smoky predecessors. Long before diesel cars became controversial for emissions, They were celebrated for sipping fuel, a virtue directly traceable to Ricardo's work. Ricardo's ideas also influenced the world of performance cars. His early advocacy for high compression and efficient combustion informed engine development at companies like Jaguar, where engineers such as William Haynes, Wally Hassan, and Harry Westlake would later build the legendary XK engine. The XK's hemispherical combustion chambers and high compression ratios were made possible by exactly the kind of octane-rated fuels Ricardo had helped standardize, and the careful mixture motion he preached. Westlake in particular drew directly from Ricardo's combustion research, applying it to Jaguar's racing engines. When Jaguar took the XK 120 to Le Mans in 1950 and later developed the C and D types, the strategy was pure Ricardo logic: win not just with raw power but with efficiency. The C type's victory in 1951, needing fewer fuel stops than rivals, was a practical demonstration of Ricardo's core belief that efficiency equals performance. So while Ricardo consulting engineers never designed a Jaguar engine outright, the philosophy he embedded in British engineering culture was very much alive at Brown's Lane. The XK engine, and later the V12, owed their ability to run high compression ratios, deliver endurance-winning economy, and avoid destructive knock-to principles Ricardo had already mapped decades earlier. What made Harry Ricardo remarkable was not only his technical genius, but his personality. Unlike many of his contemporaries, he did not seek fame or flamboyance. He rarely gave press interviews and shunned the limelight. He believed that an engineer's role was not to be a celebrity, but to quietly solve problems and leave behind better machines than the ones he had inherited. He was also deeply committed to the mentorship of younger engineers. Many of those who trained under him at the Shoreham laboratories went on to distinguished careers in British industry and academia. Sir David Pye, later Provost of University College London, and Sir Harry Tizard, a key figure in radar and jet development, were among those who passed through Ricardo's sphere of influence. Ricardo was, above all, driven by a sense of duty and curiosity. Efficiency fascinated him, not just as a technical problem, but as a moral imperative. In an age when coal and oil were consumed with little thought to scarcity or pollution, Ricardo was already asking, how can we get the most from the fuel we have? How can we design engines that waste less, travel farther, and pollute less? These questions have only grown more urgent with time. Though Ricardo's professional life was dominated by engines and laboratories, he was also very much a family man. In 1911, he married Beatrice Bertha Hale, an art student at the Slade School of Art, and daughter of the Ricardo family doctor. Together they had 3 daughters, Kate, Angela, and Camilla. The family's first home was at Walton-upon-Thames, but when Ricardo established bridge works at Shoreham-on-Sea in 1919, they moved to nearby Lancing. He loved the countryside's peace, but as development spread, the charm faded. By 1933, he and Beatrice uprooted again, purchasing Tottington Manor, a small Elizabethan estate of 250 acres. There, Ricardo indulged his love of nature, butterflies, and unusual plants. True to form, his passion for efficiency ran through his hobbies. He devised a floating greenhouse nicknamed the Queen Mary, which could be moved along water channels for optimal exposure. He recycled household hot water through heat exchangers to grow nectarines, exotic in Sussex at the time, and even captured heat from garden bonfires to warm his greenhouse. Waste to Ricardo was intolerable, whether in fuel or in daily life. When war broke out in 1940, Tottington was requisitioned by the government, and the Ricardos never returned. After the war, they settled at Graffham in West Sussex, where Harry lived until his death in 1974. By the time Ricardo retired in 1965, he was regarded as one of the great pioneers of modern engineering. He had been honoured with a knighthood in 1948 elected president of the Institution of Mechanical Engineers, and celebrated as a Fellow of the Royal Society. His autobiography, Memories and Machines, 1968, reflected not only on his achievements, but on the sweeping technological change he had witnessed, from the era of steam to the dawn of space exploration. Harry Ricardo was a lifelong heavy smoker, often remembered by his daughter Camilla for family outings in the Le Zèbre car, when he would pause to clear the carburettor with the tap of his ever-present pipe. Yet in the end it was not tobacco, but a fall that caused a pelvic injury, leading to operations from which the great engineer never recovered. Sir Harry passed away on the 18th of May 1974, at the age of 89. But his ideas live on in countless ways. Every time a motorist checks the octane rating on a fuel pump, they are using a measure derived from Ricardo's pioneering work. Every time a diesel engine powers a truck across Australia's outback or a ship across the sea, it owes something to his comet chamber and his insistence on efficient, complete combustion. Even in motorsport and high-performance car culture, a world Jaguar exemplified in the 1950s and 1960s, Ricardo's insistence on efficiency as the path to speed is still felt. Jaguar, in particular, stands as a brand whose reputation was partly built on the philosophy Ricardo championed. From the XK120 that stunned the world in 1948, through to the E-types that became icons of the 1960s, Jaguar's engines lived on the frontier between power and economy. The fact they could run such high compression ratios on commercially available fuels and sustain performance over 24 hours of Le Mans racing was possible only because Ricardo had given the industry the scientific language to master combustion. The company he founded, Ricardo PLC, remains a global engineering consultancy, with projects ranging from automotive design and clean energy to aerospace and defense. It is, in many ways, a living extension of his philosophy, that engineering progress comes not from secrecy, but from the open pursuit of knowledge and the relentless refinement of ideas. Today, Ricardo is remembered not only for his engineering genius, but also for his humility. He was never one for flamboyant self-promotion, yet he shaped the course of modern transport in ways that few others did. From the trenches of World War I to the racetracks of Le Mans, from the skies above Britain to the highways of the world, Ricardo's hand is everywhere. Right now, Ricardo PLC is a fascinating continuation of Harry Ricardo's legacy, though the scope of their work has widened enormously. At Shoreham, where Harry first set up his research base, the company still designs and manufactures very high-performance engines, often for specialist and niche volume applications. Their reputation for precision and reliability has made them the chosen partner for some of the most prestigious names in the automotive world. One of the headline projects is their partnership with McLaren Automotive. Ricardo builds the new generation of McLaren's V8 engines, including hybrid variants, which power the company's supercars and hypercars. These engines are hand-built, with extraordinary attention to detail, and represent the cutting edge of what a modern internal combustion unit can do when married to electrification. Ricardo's Performance Products division has become known for turning out high-precision, low-volume transmissions and driveline systems for supercars, motorsport, and luxury brands. In fact, they've supplied components for names like Aston Martin and Bugatti, where absolute reliability and refinement matter as much as sheer performance. Crucially, the firm also continues to research and develop internal combustion engines for a broad range of applications, from passenger cars to marine and off-highway machinery. But the modern twist is their focus on sustainable technologies, hybrids, hydrogen, and alternative fuels. It's an echo of Harry Ricardo's lifelong obsession with efficiency, translated into a 21st century setting. In short, Ricardo today remains a company at the sharp end of engineering, producing high-performance engines and transmissions that are every bit as innovative, efficient, and technically adventurous as those Harry himself dreamed up. This has been a production by Curious Jag. Please like and subscribe.